Good morning, ma'am.
Good morning, ma'am.
Good morning, Sarath. Good morning,
Good
Bhavna.
morning. So shall we start, ma'am?
Yeah.
Yeah, dear participants, I am Dr. Sarath Chandran, Assistant Professor, CSE Department of SSN College of Engineering. So we welcome all the delegates to the 5th edition of ICCIDS 2022. Congratulations to all the authors. Your papers have been selected after several reviews and scrutiny processes. Before the presentation process, a quick profile of session chairs. We have 3 session chairs for this track 1. Dr. Chitra Babu, Professor, Department of Computer Science and Engineering. She has 25 years of teaching and research experience. Her primary research area includes cloud computing, architecting big data pipelines using state-of-the-art distributed data processing frameworks, and applying principles of software engineering and software architects to these domains. She received her PhD from IIT Madras. She has published over 70 research papers in refereed journals and the proceedings of international conferences. Our next chair is Dr. Tenmuri D. She is an associate professor in Department of Computer Science and Engineering at SSN College of Engineering. She has 25 years of teaching and research experience. I request the participants to mute. Yeah, I request the participants to mute the initial stages. Yeah, Dr. D. Tenmuri is an associate professor in the Department of Computer Science and Engineering, SSN College of Engineering. She has 25 years of teaching and research experience. She received her PhD in natural language processing from Anna University, Chennai. Her research area includes NLP, machine learning, and data mining. She has published 40 research papers in the international journals and conferences. Our third chair is Dr. J. Bhuvana, associate professor in the Department of Computer Science and Engineering, SSN College of Engineering, with 22 years of teaching experience. She received her PhD from Anna University, Chennai. Her research area includes deep learning, multi-objective optimization, memetic algorithms, evolutionary algorithms, and machine learning. She has published over 18 articles in journals and international conferences. The time given for the presentation for the track 1 is 10 minutes. And then after that, 5 minutes for the discussion and question answer session. So there will be a small buzzer after 10 minutes. So we request the authors to adhere to the timings. So now the first paper. So we'll be going in this order: paper ID 8, 17, 28, 35, 72, 91, 95, and 16. Paper ID 8, comparative analysis of sensor-based human activity recognition using artificial intelligence. Author is Alagappan Swaminathan. So now you can present the paper ID 8.
Yes, I'm here, sir. Host has disabled participant screen sharing.
1 minute.
Sir, my presentation has been recorded and it goes up to 11 minutes. Would that be fine?
Yes, sir. Yes.
Okay, thank you very much. Is my screen visible, sir?
Yes, sir. Yes, sir. You can
Okay,
continue.
yes, sir.
You can start, Alagappan.
One moment, sir. I think is it not audible?
Yes, you are audible.
Okay.
Now it is not sharing, so you can share it again.
Yes,
and you can start.
I think this internal audio wasn't recorded by the.
Yeah.
Hello, everyone. Welcome to my presentation on the comparative analysis of sensor-based human activity recognition using artificial intelligence. My name is Alagappan, and this is my presentation for the International Conference on Computational Intelligence in Data Science. Since the project involves the implementation of 17 different algorithms, namely logistic regression, linear support vector classifier, random forest, radial basis function support vector machines, linear support vector machines, decision trees, gradient boosted decision trees, k nearest neighbors, naive Bayes, long short-term memory, convolutional neural networks, ensemble models of unidirectional and bidirectional long short-term memory with convolutional neural networks. There's a presentation document as well, sir. I am attaching it to the chat for the reference of audience.
Now, currently your screen is not shared, Alagappan.
Yes, sir. I wanted to share the presentation document, so I had to go back.
Okay.
For human activity recognition tasks, the data used is usually either video data or sensor data. In this project, the triaxial accelerometer and gyroscope data have been used. Recently, commercial activity trackers have become an omnipresent tool for measuring physical activities. Studies conducted by Diana Dawn and Ruben San Segundo concluded that the existing commercial activity trackers like the Fitbit are inaccurate in their classification and that they confuse between simple activities like walking upstairs, walking downstairs, sitting and standing. This table presents a list of 17 papers, the models used by those papers, and the accuracies achieved by those models. All the selected papers in the related work table are recent papers from either 2019, 2020, or 2021 using the same dataset that I've used. The papers are linked in the reference section of the presentation document. My implementation of deep belief networks achieves approximately 2% better classification results than the existing models on this public domain dataset. The raw data was recorded from the accelerometer and the gyroscope of a Samsung smartphone for 30 participants. The data recorded from the accelerometer and the gyroscope were pre-processed using the Butterworth low-pass filter with a 0.3 Hz cutoff frequency. The data was checked for null values, duplicates, elements such as the parentheses, hyphens, and comma, and they were removed from the dataset. The data was then segmented into train and test data with a 70:30 ratio. The data from 21 participants was segmented as train data, and the data from 9 participants was segmented as test data. 561 feature vectors with the time and frequency domain variables were extracted from the data by the creators. For the ML models, the features were given to the classifiers and then the models were evaluated using the performance metrics accuracy, precision, recall, F1 score, and training time. The results were then compared with that of the other models. For the deep learning models, the feature extraction step is skipped and the raw data is given directly to the models for classification after segmentation. In the link below, the original data collection process was recorded and presented to the public by the creators. The red colored signal represents the x-axis, the green colored signal represents the y-axis, and the blue colored signal represents the z-axis in the data collection video. It has no sound. The smartphone is attached to the waist. The hyperparameter tuning of the machine learning models was done using grid search CV and randomized search CV. The manual tuning was done for the deep learning models by experimenting with the activation functions, the model structure, the number of hidden units in each layer, the batch size, epochs, and the patience value in the early stopping function. The parameter tuning, as well as the best parameters of all the machine learning and deep learning models implemented and their architecture is available in the presentation document. To the left is the machine learning model linear support vector classifier that yielded the best result of 96.81%, and to the right is CNN, the best deep learning model excluding deep belief networks from the project proposal. It has yielded an accuracy of 94.06%. The common observation in all the confusion matrices of the ML models is that they confuse highly between sitting and standing, two static activities. Likewise, the DL models confuse between walking and walking upstairs, two dynamic activities. To solve this problem, a divide and conquer method is proposed. The dataset is divided into two separate datasets containing the static and dynamic activities, respectively. Deeper DL models are run on these datasets for a large number of iterations, making use of the early stopping and model checkpoint function from TensorFlow to stop the model from overfitting and to save only the best model weights. The proposed CNN architecture achieved 99.92% accuracy on the dynamic dataset, and the CNN LSTM model achieved 96.79% accuracy on the static dataset. The details of the hyperparameter tuning and the architecture are available in the presentation document. The results of all the 17 models implemented in this project in both the local instance and the EC2 instance are available in the presentation document's results table. As seen from the confusion matrices, there exists no confusion now between the dynamic activities, and the confusion is greatly reduced between the static activities. For DBN, the learning rate of the restricted Boltzmann machines in the pre-training stage and the learning rate of the artificial neural networks in the fine-tuning stage were kept constant at 0.05 and 0.1 respectively. The activation function was set to ReLU. Experimentation was done on the batch size, epochs for the RBM and ANN, and with the hidden units within the layer. Comparison plots of the accuracy versus the hyperparameters are presented. The DBN model with a batch size of 32, 2048 hidden units, pre-training and fine-tuning epoch values of 10 and 100 yielded the maximum accuracy of 99.02% on the full dataset. The confusion matrix of the DBN model indicates that the model attained 100% accuracy in classifying laying, 98% accuracy in classifying sitting and standing, 100% accuracy in classifying walking, walking upstairs, and 99% accuracy classifying walking downstairs. The bar plot on the left shows the accuracy values of all the 17 models implemented in the EC2 instance. It indicates that the DBN model yields the highest accuracy on the full dataset. The scatter plot on the right is between the accuracy values and the training time of all the 17 models implemented in the same EC2 instance. It can be inferred that the DBN model is quicker and relatively more effective, more time effective in its classification compared to the other deep learning models. That is all, sir. Thank you.
Um, good morning, Alagappan.
Good morning, ma'am.
I have a few questions. It's a different presentation. Generally, we see physical presentation and this time a recorded one. Anyway, fine. I want to know what are the list of activities you consider.
Yes, ma'am. The list of activities are sitting, standing, walking upstairs.
So that
Yes, ma'am.
number of activities actually, can you
Six,
tell me?
ma'am. 6, ma'am.
6 activities.
Only
Okay.
6, ma'am.
Okay. And what would be the data format actually? All are signals just, or
Yes, ma'am.
is
Signals,
there
ma'am.
is
Signals,
there
ma'am.
any other? Okay. And I have set of questions. I have noted them.
Yes, ma'am.
And you claim that you have collected this data set
No, ma'am.
using.
I have not claimed. I'm not claimed that I collected it. I used the donated data set by this group of data collectors.
Okay. Actually, did you heard about CASA's data set for activity recognition?
Not really.
Which is
ma'am. Yes, ma'am.
CASA's CASAS data set, which is a benchmark data set
Okay.
globally used by researchers of this activity monitoring thing, and
Okay.
which involves around like more than 30 activities they are monitoring.
Okay.
And another thing I want to ask you is,
Yes, ma'am.
basically this activity monitoring is required for elderly people, but
Yes, ma'am.
whatever the data you have collected for the age between, I think, lesser than 40, 45 something.
Yes, ma'am.
Is there any reason for that to restrict with this age group, or
Yes,
what
ma'am.
is the motivation?
It is a sensitive area to collect data from elderly people, ma'am, and general public are not usually allowed to collect. And there's a list of institutional requirements that need to be satisfied before engaging in a conversation representing the institute to collect data, ma'am. So most universities and students, they usually do not collect data from elderly people, ma'am. The application is for the elderly. Yes, ma'am.
Because for that is actually whatever the data set I'm telling now, the CASA's
ma'am.
data set, which has been collected even from the elderly, and which so you can experiment your work on that data set so that you can compare like how your
Yes, ma'am.
method is fitting to the data set and problem, and you can compare it with the state of art the approaches, rather than choosing a small data set with only 6 activities.
Yes,
So
ma'am.
you can extend this with the benchmark gold standard data set called CASAS. And
I
what
agree, ma'am.
yeah what could be the format of this particular data set?
Format as in
How did you store the values? Only signals or any other information you maintain?
only signals, ma'am. The algorithms did the rest. I converted the signals to labels. Actually, the data set collectors, they gave particular labels for the particular set of patients, and based on that data, I was able to classify the signals to connect the signals with the features.
Okay, what for ML approaches, what are the features?
There are around 561 features, ma'am. They
Okay.
were created by the dataset creators, and I think CASAS is a relatively newer dataset, probably.
No. It is there for a decade, I think.
Okay, ma'am. That is one of the disadvantages of this project, ma'am. I wasn't able
I'm
to
not telling it is a
compare it.
disadvantage. Maybe you have not explored to that. You just go through that, and you
Yes,
can compare with state of art approaches if you use that one.
Thank you, ma'am. This was the same feedback I received by another author as well, ma'am.
Okay. This is from my side. Okay.
May I ask now?
Yeah, go ahead, Prema.
And you applied a deep belief network, right, Ragappan?
Yes, ma'am, I did that.
Okay. Can you tell me what part of the DBN have given the better performance? You said you classified the static activities and the dynamic activities, and then you applied the DBN, and you shown us the confusion matrix with the better performance. Can you tell us what feature of the DBN gave you that better performance?
Ma'am, as per the chart shown in the conclusion slide, it is evident that the hidden layers of value 2048 and batch size 32 yielded the best results, ma'am. And this was for the full data set.
Aragappan, I think that is not the question, if I understand, Bhuwana.
Yes.
I also had the same question in my mind.
I'm
You
sorry.
had tried 16 or 17 different models,
Yes,
right?
ma'am. Yes, ma'am.
And in that, you are claiming that this deep belief network is the one which is performing best among all the models.
Yes,
so, if I understand Bhuwana correctly, that is, what is the characteristic of deep belief network which is making it to perform in a best way for your this activity recognition data set compared to the rest of the models?
Yes.
I think it is a combination of the pre-trained RBM with ANN. The model is pre-trained, and after pre-training, it is fine-tuned with the artificial neural networks. That is how deep belief networks work. And I think that is the key factor, that is the pre-training stage is the key factor that separates it from the other deep belief networks, which is directly fed to the neural network. So the Boltzmann's machine constants, the RBMs which I used to pre-train are what separates it, is what is my understanding of.
If my understanding is correct, you can also get a pre-trained CNN model and then do the same thing for your thing. So is pre-training the key thing which has given you this best performance or something else?
I haven't quite looked into this, ma'am, but I think it is the RBM that makes the difference.
Okay, the interpretation is more important. That is, you have done all this and run several. And also, I would like to know whether you did it for the data set for all these 17 things, or some of the earlier works have done it and you did.
That's the key. That is one of the aspects of this project as well, ma'am. All these algorithms have been primarily used in other data sets and other projects, or in this same data set by other authors in varying timelines. But the values and the tuning was widely varying, and the accuracies were different for the same algorithm implemented by different authors. So to bring it all together under one paper for the analysis, compared to analysis, it was all done by me, ma'am. It was all implemented and tuned by me. So all the 17 algorithms were done in this paper, and it can be compared.
Okay. So the same algorithm could have been tried by the other authors with a different hyperparameter tuning, but you have done it in certain way.
Yes,
so you are able to compare it in a unified way.
Yes, ma'am. And also they don't particularly show us all the hyperparameters in the exact values, but I mention every hyperparameter value in the documentation that I've sent in the chat, and it is also part of the paper.
Okay, yeah, but a little bit more of interpretation, that is, if a reasoning or rationale behind why this particular deep belief network is giving this best results, that would be good to see. Yeah,
I agree. Okay.
Is there any objective to conduct all these, networks, to apply all these networks on this data set? You have any, specific objective to do this?
Yes, ma'am. The objective is for personal learning. The personal learning as in learning about oneself with the different activities. The project initially began as something that was to be complex with more activities, but due to time constraints, I had to limit myself, and I had to use a lot of implementations, and so I preferred to go with a smaller data set that was widely used even in recent years. But the main objective was to understand one's activities using their own smartphone. The project was supposed to be in its entirety one that could be used personally to monitor their own activities with an algorithm and
get updates on their mobile. This would be the next step of the project continuation.
Okay, Sarath, we can
Okay.
go to the next one.
Okay.
Thank you very much.
Thank you,
Thank you.
Alagappan. Thank you, Alagappan.
Yeah.
So the next paper is paper ID 17. The title is Factual Data Protection Procedure on IoT-based Customized Medicament Innovations. Dr. N. Srinivasan and Dr. N. Ananda Sivaprakash. Sir, over to you.
Good morning, madam. This is Dr. N. Srinivasan.
Good morning, sir. You can proceed.
Yeah. I'll share my screen now.
Yes, sir. You can share.
Yeah.
Share.
The screen is visible.
Yes, sir. You can proceed.
Yeah.
You can make it as full screen and then you can proceed.
Yeah. Okay. Yeah. Good morning to all of you. The thing is, no, today I forgot to bring my reading glasses. Anyway, our topic is factual data protection procedure for IoT-based customized medicament innovations. The objective here is not only IoT with sensor with high security and safer interaction for all the medical devices. Nowadays, we are using the higher packet distribution ratio, end-to-end throughput rate, and overhead routing for the stated scenario, even if the transmission messages was correspondingly. Survey we had did a survey on different methods and identify some best method, right? And then here in our abstract, it says normally the basic values in urban communities in terms of smart world modified quickly by innovative industry. So the Internet of Medical Stuff infrastructure need and other in the medical industry. So the need of smart mobile devices or gadgets to store the patient medical records in terms of EHR and electronic, normally electronic health records are used. We are using electronic health records, and it is continuously monitored in the medical world. And the problem in the IOM is the problem in the Institute of Medicine. The safety and protection of medical data is more important here nowadays. And so we are in need of a user authentication protocol based anonymity, which solves problems in the Institute of Medicine about the security of privacy and ensures safe interaction. So the need of smart healthcare, which is a reliable and transparent facial recognition, user identification techniques should be there. So it has high safety characteristics to develop intelligent IOM health application systems. As a result of performance review, normally it uses the ADV routing protocol, and we had did some simulate. We experiment results are there in NS3. The performance, we are introducing a new proposed system called as this secure and anonymous biometric-based user authentication scheme that is called as SAP and UAS scheme. And yeah, so here in the introduction says that IoT without human intervention to take an indigenous decision. IoT devices are semi-structured and structured in temperament. Medical electronic devices, a wireless sensor are used to collect and store data. Problem main here is the user authentication, where and who is authenticate for the whole management system in terms of HMS or whatever the end-to-end application the system has. So based on the user authentication, because of the user authentication, we need a standard IoT model for any medical healthcare system for safety and efficiency. Due to the insecurity of data sharing across the public networks nowadays, because that is a major issue here, because of the insecurity of data sharing across the public, because nowadays we know, I mean, all the medical records, EHR, I mean, we have HL7 records now in healthcare 7, and these healthcare HL7 standard records in terms of EHR in the sense electronic health records, and all the hospital which are using across the world will be sharing their public data sharing through the public networks. So the authentication here is more important. So this is about our diagram. This diagram shows about see here. This diagram in COVID-19. We have I mean, like our this, app is the right, like the Practo app. Practo is the application which is used in India, but yeah, across the Europe, in Malaysia, I mean, Mekenko is an app, whereas that application helps connects the patient and the doctors or physicians, and all the records has been shared electronically. So we need to have a secure packet transmission method for doing it. So here this particular diagram shows a IOMT platform. It's a cloud-based system, and it connects with the hospital. It connects with the Center for Disease Control and the local health bureau, right? And here we have all the I mean, the consultation will be purely based on online health consultation has been done, and all the tests has been done, and the test records has been done electronically. It has been converted into EHR, and it has been transmitted safely to the particular stakeholders, right? So here the literature review, there are many papers which are based on that, but our review states, I mean, our study, we purely focused on this particular algorithm that SAS, I mean, secured packet, secure and anonymous biometric based user authentication scheme that we had proposed. And this particular algorithm in the previous work, no, I mean, this Madhusudanan and all other authors did a multiple crypto system programming techniques, whereas this, I mean, Rato and all proposed a protected authentication mechanism on the basis of RSA algorithm, as well as DH for was implemented for wireless sensor networks. And Wong and all, I mean, the authors, the paper, I mean, they have proposed a hash-based dynamically authenticated device, whereas it was a old device, but it is not connected with the IoT. Yoon and Kim, they had proposed a good biometric user verification for doing it. So Park and the authors in 2016, they had proposed a wireless sensor networks deal with different environmental structures. And Ya et al. In the year 2016, yeah, in 2016, they had proposed the two-factor authentication for WSNs. They had constructed a system, and in the year and authors proposed a key sharing mechanism with duplicating smart cards and sensor energy supplies. And Lee in 2018, they had proposed a radio frequency identification authentication protocol for Internet of Things. And Chebyshev and Chaotic map, they had proposed, I mean, Lee proposed a Chebyshev and Chaotic map for three-part user authentication protocol to offer the evidence of the client secrecy. See, actually, not only the client secrecy we have to maintain a lot in cloud-based authentications. for sharing the data, electronic data. And Hamid and authors in 2018, they had proposed the IoT-based wireless sensor networks. They had presented an integrative data integrity protocol via gateway control information. The gateway control information is from the base station actually. And Tudman and et al. Tudman and et al. In 2019, they have created a surface architecture to make mobile devices, IoT, and cloud services more interoperable, consistent, and adaptable. And in 2019, again, Tudman proposed a cloud-based system for primary agreements that is based on the IoT. Here, the primary agreements is the level of authentication, which is in terms of secure socket layer mechanism, SSL layers. They had made agreements with the SSL socket layer, SSL layer. Deepak proposed IoT hash-based RFID authentication, that is context-aware method. Lee, again in 2018, have created a ECC-based IoT environment authentication protocol that uses biometrics to authenticate service access. Challa and others, they had implemented an ECC-based user authentication technique for prospective IoT deployments. Wazir et al. Have proposed a stable, lightweight IoT network cryptography. Roy et al. Subsequently proposed a new crowdsourcing IoT users environment. Again, Wazir et al. Proposed the latest verification method to access the validity of medicinal, dosages schemes for medical counterfeiting. Tudman et al. Proposed the asset context sensitive knowledge function to seamless shared authentication mechanism for Internet of Things. Now, we had given a secure encrypted face recognition method that is called as our secure and anonymous biometric based user authentication scheme is presented here. And the proposed system here, what we are doing in the sense, the data from the data center is captured using WGAC, that is called as whole genome analysis comparison tool. The passwords of the current SAB UA scheme are safely passed to avoid a privileged insiders attack. We are creating a long-lasting privacy key using a one-way hash function. In addition, master keys like MX and IUS BTI are used for storing the PI values. The derivative UID is impracticable in the proposed system to achieve the user identity preservation function. And the ADV attempts to take care of some of the J sensor nodes that create communications with user in the proposed model. However, as designed or constructed using NI, ADV does not easily catch. So the suggested SAB UAS framework that notes that ADV was unable to efficiently operate this result. So here we have proposed a new system. This particular system works in this SDN domain, software defined networking domain. Here we have a cloud-based security controller. We have SDN domain, which scans the virus if there any virus is there, and we have many client machines which are in this particular SDN, and we have a security controller here to map the particular thing whether the user is the authorized user or not. So here authentication has been we had given a SDN. SDN for we are just mapping our thing in this particular architecture deals with mapping of our scheme, our protocol. We can say that it is an authentication scheme we have written over the particular SDN. All right. So here the results, the efficiency comparison is relative to other existing systems for contact bodies such as user WGAC or MSJ that deliver times the system are less costly. The suggested SABUA scheme is believed to be durable and reliable. It has been done in NS3 2.8 simulator on the Ubuntu cluster on LTS platforms. So the PDR ratio of suggested SAB UAS degrades dramatically as the number of sensors grows. The graphs has been given in the this thing. We had taken some sensor nodes and we had compared the throughput rate and our proposed scheme. SABS gives some good performance throughput rate, and the delay comparison has been given here, and the performance based. This is again. That particular graph says that yeah. So values here this particular graph says about packet delivery with packet delivery with delay. Yeah, delay comparison. Yeah, yeah, it is compared with the number of sensor nodes with the packet delay ratio. Yeah, packet delivery ratio. Here, the delivery ratio here is comparatively high, right? So this shows that whenever if we go for this particular scheme, it gives some good results. This is about the packet delivery comparison, ratio comparison in terms of mobility with routing overhead. And again, here, based upon the other works now, here our model gives better prediction ratios. So the majority of wireless standards star network topology wherein every node sensor communicates directly with the ground station. The consequence is that the node and the base station have high asymmetric connections. The data flow consists of acknowledging or clear commands or actions from base station to access point to point or pointing traffic from base station to the particular node. The asymmetric design tends to concentrate all of the complexity in the base station, resulting in simpler and devices with the lower cost and high battery capacity. On the other hand, this has a detrimental impact on the scalability and quality of operation of LPWA technology. So the conclusion here is the proposed regime increases the resource utilization for development of smart e-health networks, including energy, computing, and connectivity. The sensor nodes, including the packet distribution, end-to-end latency, and include or tested with the NS3 and network simulator. The suggested scheme becomes more crowded as the amount of data delivered increases proportionally due to the addition of sensors in the row. The proposed SAB and UAS could achieve a higher packet distribution ratio, end-to-end throughput rate, and overhead routing for the stated scenario, even if the transmission of messages goes correspondingly. So this is about, so our scheme gives a good results actually. Yeah, thank you. Hello.
Yes, can you please go to the architecture diagram you have shown?
Just a minute.
That's smart.
Just a minute. This one, or you want to?
You proposed a system diagram.
Yeah, yeah. Just a minute.
Okay.
This one, right?
Okay. You listed too many, papers, and you reviewed you surveyed those papers, right?
Yes,
You have not summarized what you inferred from all those and what you have taken up to address as the solution in your proposed work.
That our the other professor, Dr. Another sir will just give the inferences.
Actually, good morning. Good afternoon, madam. Hello.
Good morning. Yes, please proceed.
Actually, we made a lot of survey on the different paper. Based on this work, we can take the best method, and based on the 4 criteria. So we have in the short ILG, the packet delivery, and 1 second. This one. And so we studied this different paper, and from this paper we analyze the different method on which we take the packet processing speed and end-to-end delay, throughput speed, and in the cloud speed. So these are the factor. Based on the factor, we study the different paper and come to the conclusion that this is the best method for this one.
Sir, in line with madam, actually, it would be better if you conclude with the research gap and what is your real objective, because we find difficulty in understanding what is your core objective, whether you want to improve some performance or you want to apply to some application. So
yeah, it is normally used in the medical application. In the medical application, these are the problem we are facing. The packet distribution ratio, what is the packet distribution? When you are using the cloud system, the packet distribution ratio will be reduced, and the end-to-end throughput ratio on overhead routing. And these are the problems. So we have how to rectify that kind of problems. So we have to make a survey.
Actually, ma'am, yeah, I will also join with him. The thing is now the previous evidence, work suggests the framework proposed, the previous framework proposed will shield the user's personal information from the opponents and to obtain for a fulfill confidentiality. Sometimes the base study illustrates that the emerging system greatly decreases the costs of storage actually. So we have proposed this particular system, and this particular system, our system suggests, our SAS system suggests it becomes more crowded as the amount of data delivered increases proportionally due to the addition of sensors in a row. Right, this can be a gap with we have found that this particular thing is a research gap actually. However, with other digital UAS or certificates, or we used to call it as SSL certificates whenever authentication has been done, the proposed SAB UAS could achieve a higher packet distribution ratio and the end-to-end throughput rate also.
How will you calculate these metrics?
So based on this one, we come to the conclusion that this is our method is the best method based on this method.
Yes, actually we have to implement it.
That is
Okay.
okay.
Chitra madam, so
yeah, please go to the next one. I do not have any question. They have already asked. Thank you. Yeah.
Okay. Thank you, ma'am.
Thank you.
Thank you. Thank you.
Thank you, madam, and thank you, sirs.
So we
Our
can
next
leave.
paper ID is?
Can I
Yes,
leave?
yes.
Can we leave?
Yes. Okay, thank you.
Yes, sir. Thank you, sir. Our next paper ID, the track one is paper ID 28, a survey on techniques and methods of recommender systems. Authors are Anil Reval and Dr. Komal Boris Sagar.
Yes, sir.
You have 10 minutes.
Okay, sir.
You can go.
Good afternoon, ma'am. Good afternoon, sir. Myself, Anil Rawal. I'm a PhD student at GTU at Ahmedabad, and I will be presenting on survey on techniques and methods of recommender system. Here is the outline. Now, the only reason behind the rise of recommender system was increased use of YouTube, Amazon, Netflix, and many other such web services, resulting in diverse and high volume data from multiple sources. The value of this content is paramounting, as this data can reveal a lot about any person's personal and professional life, and general applications can be seen in e-commercing and online advertising. Now, foremost, why there is a need of recommender system. So when manual feedback were considered, those are voluntary, which means one can either participate or not, or one can give fake reviews influenced by others. That's why a better way is to track down their behaviors like conversation or post on social media, click-through rate, or even information like kind of items a user is interested in, whether because of taste or season. So consequently, this task can reduce transaction cost of finding and selecting items in an online shopping environment, and in turn can simulate demand and can actively engage users. Next need of AI in recommender system is for determining correlation between users and items, representing tricky data with complex pattern, and thus reducing compendious effect regarding contextual, demographical, and geographical data. Motivation behind development of this kind of systems are: first, it can provide the user with potentially more relevant items without manual feedback with the help of just customer base. And second, it can provide a personalized experience without compromising user data privacy, inferring needed information from available bulk. Now, here are some traditional methods. The first one is content-based, which use similarity in features to make decisions, comparing user interest to product features, and thus classifying product with the specific keywords. It further has two types. First one, vector, uses similarity distance, generally cosine, to determine distance between vector of item and user. And the second one, classification approach, uses decision tree like algorithms. Second one, collaborative filter. So this is solely based on previous interaction between users and target items. And its first type, model based, considers a rating estimation which can either be any real valued number or binary value. So along with it, before matrix factorization, techniques like neural network, logistic regression, Bayesian network, or even SVM can be applied. And in second one, for memory based system, they use rating to calculate similarity among items. And as of its example, item based, user based top end recommendations, or even neighbor based systems can be thought. Third, in demographic method, appropriate market analysis within a peculiar region escorted with a needed survey or inspection is must. Now, fourth one, knowledge based method, summarize understanding of how a specific object will meet a person's want, and thus it will show, depict connection between want and a piece of likely advice. Fifth, in utility based, calculation of every item's usage for a person is done. And in final type hybrid, it combines the power of any two recommender systems. Literature review. So it was needed as traditional system were not competent to unstructured data. So many techniques have been proposed. First is deep learning based methods. So paper 1 shows how different kinds of data like text, image, videos, etc. motivated the use of deep learning in recommender systems. Then second paper used restricted Boltzmann machine. Then as an extension to this work, RBM for collaborative filtering by two-layer DL model crammed by RBM was developed to search for the ordinal ratings. Then systems using NLP was seen by linear and nonlinear relationship modeling with the help of machine factorization for feature engineering. Now here, to model linear relationship in concurrence with matrix factorization, neural collaborative filtering was also applied for user product nonlinear relation prototyping. Then a system was developed combining autoencoders and matrix factorization to learn user product nonlinear latent relationships. Apart from this, a sequential recommender system was designed combining short and long-term user preference and applying fine-tuning using hierarchical attention network. Then an adversarial personalized ranking for recommendation used user item embedding with notion of Bayesian personalization ranking as an adversarial regularizer. Now, differing all above systems, generative adversarial network based model was presented to learn user item preference and interaction for knowledge graph. Apart from that, CNN based models like DeepCon, ConMF, RNN, LSTM, GNN, GAN, ResNet 50, VGG19, VGG16, exception, and even Inception V3 have also been used. Next comes transfer learning based system. So first paper here extract features from image and thereby applies feature for user based collaborative filtering for the task of movie recommendations. Then a system combining zero-shot learning and autoencoders was used to learn item-item representation for cold start search. Then some extended versions of autoencoders like CDAE, CDAE, CF, DAECI, etc. were also applied for the same task. And apart from this, combination of transfer learning was seen with hidden Markov model and collaborative filtering too. Now comes active learning based methods. So here the first paper for the task of movie recommendations used Gibbs sampling with Bayesian non-negative matrix factorization. Here the second paper had an interesting use of AL where they proposed an approach for recommendation with initially user clustering to groups, then representative from each group was selected and using one hot representation of users likeliness, item ratings and its variance were calculated. And in third paper, they developed a system called Polar++ with the help of Bayesian neural networks and attention-based CNN. Now, reinforcement learning based methods has proven to be good for online frequently and updating data. So as a part of these RL based methods, different techniques like attention layer with GNN, deep Q network, then exploration based, then deep Q learning, cross feature bandit, sequential feature bandit, Markov decision process, and even RNN was applied for the task of item recommendation and news recommendation. But a different application was seen when this reinforcement learning based recommender system was used in mobile age computing to improve the throughput. When soft computation techniques are considered, usage of soft rough sets and C-mean clustering was seen. Considering NLP methods, different techniques like text similarity or summary, semantic analysis of document, obtaining logical relations with named entity recognition, and grammar-based extractors were also seen in application for the task of article recommendation. So here the third paper developed the recommender system to recommend papers and articles that are related to a particular topic of interest, considering the citations, keywords, and summary. My research findings and identified research scope are that still data sparsity and scalability is an issue for recommender system, along with addressal of cold start and warm start problem for long-term recommendation. And second thing, instead of focusing on just product or user product recommendations, if events are targeted with multi-aspect tasks, then it will be more convenient. Besides use of graph or visual representations, either for embeddings or visualization, or maybe for tracing the query click, can be more effective. Now, although the comparison of different techniques among papers was strenuous because each study was carried out on dedicated population and sample distribution, which had its own dedicated specific characteristic. So all I have detected here is there is a need of event-related or seasonal recommendation task with multitask aspect. And secondly, a mechanism to handle huge and frequently updating data and its adaptation to online environments accordingly needs to be understood. Concluding here, target is to build up a recommender system which can handle data and can solve real-time problems with more accuracy on results, either with the help of DL or RL or integrating both. And visualization can also be applied for accurate and easy designing. Thank you. It's all from my side.
So, is this a review kind of paper? Have you implemented any of these?
No, it's a survey paper. Still,
Being a survey paper, you are presenting all the works done, right? So you should have refer it. The reference number can be given for all the papers, right? So that is one minimal thing you have to do. And moreover, it's a recommender system is a well-known application. It is happening for a very long time, and whatever the research gaps you are identifying, is it adequate for continuing this research, or is it substantial to show the scope for doing research in this recommender field? Show your research gap or your research direction, something. So is it giving any insights that we can continue our research in this recommender system?
Yes, ma'am. As per my survey, I have seen very less work on this target event-based systems that target any event or season.
Anil, yeah, thank you for the presentation. But like Tenmuri is saying, that is when you are doing a survey paper or reviewing existing literature, it will be nice if you can bring in a new perspective, like something like a insight which you are unique insight which you are bringing in by grouping them in a certain way and then saying that this is something which you have come up with, that insight. That would have been a good thing. Yes, you have tried to do, but a little bit more could have been a nice thing. Especially, can you answer this question, that is this long tail items with sparse interactions? So for that, which of your, you have shown so many recommender systems,
Yes.
which one is a suitable one for handling that kind of long tail items where there is a lot of sparsity? So that, can you tell?
Ma'am, as per my survey, compared to all those traditional system, it will be better if zero shot learning or any other kind like transfer learning is used for the same.
That's very generic. So what exactly is zero shot learning? Why is it actually better for this?
Because there we have been given with only one instance of training data.
Okay.
That's why it will be able to handle cold start problem.
Generally, one-shot learning or K-shot learning, people will use for data with very less labeled data. Okay, so with the number of labels or the annotation is very low quality, there people go for that one-shot learning and other things. Do you feel that for the recommender system that method suits?
Yes, ma'am, because in the starting, we will not have any kind of user data or user history. That's why.
Yeah, that seems to be a logical answer, that
Okay.
because you have less data and it is very
You
sparse,
need to recommend more.
Sparse,
Yes.
and very rarely people would have bought that or done something, and for that you have to come up with the recommendation. So you are trying to use zero shot learning, but have you come across that is already applied, and in your survey you are talking about few shot and zero shot learning performing better for such kind of sparse data in the recommender systems, right? So what exactly you have identified as the research scope in this?
Okay, my identified research scope are two. First of all, data sparsity with addressal of cold start problem where we won't have any data. And second scope is that it needs a multi-task recommendations targeting events. Like they are recommending according to season and not as usual, usually as about preference and taste or considering history and all.
Yeah, just now you said, Anil, the data sparsity problem is kind of adequately addressed by zero shot or few shot learning.
Yes.
So do you still see gaps in that, and do you want to work on that part? Where exactly is the gap, and why is it still not able to adequately address this data sparsity problem?
No, ma'am, I will read on it, data sparsity.
Okay. Yeah. Donna or Tenmuri, you can take over.
I don't have any questions. So
Okay, that's all from my side too, ma'am.
Okay. Okay, Anil. Thank you. Thank you for the presentation.
One recommendation, you can include this in your paper also. Have a you need to summarize the research works based on some categories. What is the data set they used? What could be, that is for each of the category, what are the open challenges still persist? Instead of listing all the papers and its methodology as a table, you just collect them based on some technology, or you group it as something, some
Anil,
interesting,
like a taxonomy would be a good outcome
yeah.
of a survey paper. If you are doing that, that would be of a value to others who would like
Yeah.
to pursue.
For each type of recommender system, what could be the, that is, instead of telling as a whole, for each of the, for a collaborative recommendation system, what could be the research gap, like that. For each of the things, if you list it, all the research gaps, and finally if you provide some recommendations to the users, research insights to the user, it would be a great thing. Okay, because
Okay, ma'am.
fine, do that. Thank you.
Yes, ma'am. Thank you.
Thank you, Anna. Our next paper ID is paper ID 35, assessing layer normalization with Brad's MRI data in convolutional neural network.
Yes.
Akhilesh Rawat and Rajiv Kumar.
Yes.
You can start. Next 10 minutes is yours.
Have you already shown my slide?
Yes, Akhilesh, you can proceed.
Well, hello everyone. Good afternoon. I am Akhilesh Rawat. I am pursuing PhD from Jawaharlal University under the Professor Rajiv Kumar, and my topic is assessing generalization in deep learning architecture with medical image data. My outlines are first one is introduction. After that, we discuss the normalization method, which are used in deep learning model to achieve generalization. After that, we discuss some literature survey, and that then we discuss the data set which are used in OL paper. After that, we used define the 3D unit architecture, and for last experimental analysis, and we conclude with conclusion. Now we start with the introduction. The deep learning based CNN model architecture are commonly used in medical imaging. The main problem in the medical imaging and medical field, that is the data is highly imbalanced. None of the machine learning technique, despite all the advances, can address meaningfully. We train the data, we learn we do learning, but we generalization ability most being ignored because of the several challenges, several technological challenges. The highly imbalanced means that the target classes has an uneven distribution. That means one class level has a very high number of observation, and another has a very low number of observation. This paper is accessing a layer normalization technique in CNN-based architecture, CNN-based 3D unit architecture, and faster training for better generalization. The layer normalization is mostly used in natural language processing tasks such as question answering, handwriting, sequence generation, and extra, along with the recurrent neural network. Now, this is not yet to export in the field of medical imaging. We use brain MRI segmentation and train our model with layer normalization and without normalization, and see the impact of both model, how the normalization affect the model. We use Brad's 2016-2017 dataset for brain MRI tumor segmentation and applying layer normalization on CNN-based 3D unit architecture. Now we discuss what is generalization. That defines how machine learning can work with acceptable performance on the data that have not seen. This is real problem in medical imaging. The first graph is clearly shown that the training is performed quite well, but during the testing, when we not applying the generalization techniques, it's going poor. But when we applied the generalization technique, then it's between the gap of the training and testing, it reduces. This graph it stands to the better generalization. Now we discussed about how what is the basic technique of how the CNN convolutional neural network work. The CNN convolutional neural network also known as the CNN. It is the artificial neural network that is so far being most popularly used on analyzing the images. CNN mostly used in pattern detection in image analysis. The CNN hidden layers are called convolution layer. Through the filters, there are the filters. They are the one image, and we apply the different types of filters and detect the patterns from the images, like edge, circles, circle, corners, extra the type of features. These let us suppose this is an input image, and we apply the different type of filters, and we extract some features, and the group them features is called the feature map, and we apply the after the get the feature map, we performing the pooling, and this operation repeatedly many times. Then we apply the fully connected layer, and operation flatter operation applied. Then we last get the over output. Now we discuss what is the normalization. Normalization is the technique, the normalization process on the image as well as feature map. We apply the normalization on both image as well as the feature map values. The normalization addresses the problem of covariate shift. That means the distribution of the input data shifts between the during training environment and or live environment. After the applying normalization, all the attributes in the final decision making process is more or less or same. At the right side, there are different types of normalization: batch normalization, layer normalization, instance normalization, and group normalization. At the right side, we arrange the number of example on the x-axis and the number of channels on the c-axis, and each cell of the this graph is represented as width and height of the feature map. Now we discuss what is the batch normalization. The batch normalization normally used by many authors in the medical imaging field. They collect the identical channels from the training example in the same batches, group them together, and find their standard deviation and mean. After calculating the value of standard deviation or mean from the identical channels, like this type of, they calculate all the standard deviation of the mean of these channels. Then fundamentally, by mathematically we seen that the input is x, which is all the values are identical, belong to this channel. Then we output of the normalized batch normalization, we get the normalized value of all these values. Through this formula, we calculate the mean of these values, and for the variance, first we calculate the variance, then we calculate the standard deviation of these values. When we calculate both the values, when we use this formula to normalize all these values in batch normalization, we finally the last equation. This is the equation. This equation is used for the reparameterization during the backpropagation. And during the backpropagation, gamma and these values, gamma and beta, are tunable with the same gradient procedure and the weight vector of the neural network. In the batch normalization, we cannot normalize all data unless the entire batch, all the entire batch is processed, where the x is the represent the one feature element in the channel C at location ij. This is the location ij, or this is the x represent the all. When we increase the I and j, this is the change the values of x. Then the mu c is the mini batch of mean. This is the mini batches, and the mu is defined as the mean of their distribution, and the sigma is the standard deviation. Then we calculate the normalization where the gamma becomes the standard deviation, reparameterized data, and beta becomes the mean of the reparameterized data. Then we discuss how the layer normalization technique, how to work. We calculate the mean and standard deviation of the same data across the same layer. Not we different batches, calculate the different batches, same identical batches. We calculate the standard deviation of the same data across the same layer. That's we calculate the standard deviation of this mean. The same we use the calculate the mean and standard deviation, and after that we normalize the data. Then we reparameterize the data. Here the same procedure we apply the batch normalization, where the x mu are same. And now is the instance normalization. In the instance normalization, we calculate the mean and standard deviation same data across the same layer. Now so in the instance normalization, we calculate the same data in the instance normalization, but means we calculate standard deviation of this instance within now this instance, and so far we calculate all the standard deviation and means of all the instances. Then we and calculate the output of this distribution, output of the normal distribution, sorry, instance normalization, and then we calculate the mean and standard deviation. Both formula used to normalize this value, of same procedure as the defined in the batch normalization and group layer normalization. After that, we discuss the group normalization. In the group normalization, the different channels are grouped into different groups after computing sigma and mu. There's the standard deviation. We normalize the feature belonging to the different groups only. With respect with the corresponding the mu and sigma, the whole channel is divided into the many groups. So C equal to G and C dash, the number of groups, and C dash the number of channels per groups. Then we use the standard deviation and calculate the standard deviation and mean. After that, we will normalize the value. After that, we reparameterize the data, and we hence we use normalization and normalize the value. For my paper, we use the Bain MRI dataset. The Bain MRI dataset multi-sequence data, Bain segmentation, the BRATS 2016 and BRATS 2017 dataset. Simpson et al. Combined these dataset and made them publicly available. This dataset was used in challenge and brain tumor segmentation organized by the medical segmentation decathlon. The segmentation task aims to 3 billion tumor, edema, non-enhancing tumor, and enhancing tumor. All images are of 4-dimensional area of size 2 x 40, 240, and 160 x 4. The MRI scans are they are T1 weighted and T1 post gadolinium and T1 weighted. These are the images are used in my paper. That there are some research literature review. The Simpson et al. First tackle the problem of covariate shift. They defined the shift in distribution of network activation caused by the training of changes. In Leif and Shajiri in 2015, they tackled this, reduce the covariate shift problem by using the batch normalization, and they use the MINIS data set and applying the batch normalization with the batch size.
Sorry to interrupt, Rawat. Can you skip this literature survey? You can
Yes,
conclude with the identified research gaps from the literature survey, and then you can proceed with your methodology.
The research gap only is all the authors use the batch normalization and layer normalization, group normalization and instance normalization medical imaging, but the layer normalization is not used in the medical imaging yet. So there, because the layer normalization is the bad at all, you use the for image sentence ranking, contextual modeling, and NLP tasks. So we trying to accessing layer normalization in this field. So we use the 3D unit deep learning architecture. Yeah, this model is used for automated image segmentation. We use for brain MRI image segmentation. Sorry, this model used for automated segmentation model. We use the brain tumor image segmentation for this model. It includes the encoder part, and also this is called the decoder part. Also called the contraction and expansion part. This shape basically formed in U. So is called the U shape. Multidimensional MRI images are given in the input data. The first 3 dimensions present each point in 3D volume called voxel. The 4th dimension is accurately detecting tumor identification by providing additional information beyond the voxel data. We extract 5 subvolumes from each input data, effectively train a test model. Each subvolume is 160 x 160 x 4. We remove those subvolumes that contains 5% tumor regions. We use the SD5 format for the stored the data and some module. Basically this is my input of the 3 dimension brain MRI images. For training, we have used 1560 subvolumes and 440 subvolumes for validation. The input layer is followed by the doing sampling. This is our down sampling unit, and with the layer normalization, we apply the convolution, then we apply the layer normalization and ReLU and dropout function. We use the 25% dropout, the normalization activation dropout. The pool size of this model is 2 x 2 x 2. The network with the 25% dropout rate has 4 downsampling units. There are 1, 2, 3, 4, and the 4 upsampling at the time at the final layer. Each upsampling containing concatenation of layers. The neural network ReLU activation function you use, and then sigmoid activation used for the final layer. And then we discuss the results. Over the results, we use the 6 GB NVIDIA graphics and a TX system. They have this is 144 GHz GPU and 16 GB RAM. We utilize Python as a library. Python is the platform, and we use Keras and TensorFlow. as library for the experiment. We use the for training, we use this 50 pouches, and learning it 10 choose to -4. Training takes around 1 day to complete the training iteration. So in above, this is our results. In above figure, this training and validation loss they keeps on changing with ups and downs in the error. However, both training and validation loss converge after some particular approaches. Layer nomination architecture gives 32% less validation loss than without nomination based architecture. That this demonstrates that the layer nomination based model outperforms the competition and provide stability. Additionally, we calculate the dice coefficient figure. This figure shows the without nomination based model, and this figure with nomination based model. And we listed that the validation dice coefficient in LN based design has increased by 17.5% when LN is used. Hence, it shows the LN based approach gives better prediction and generalizability than without the nomination based approach. This is the tumor randomly taken by the one model. This is the image, a ground truth, and this is the prediction. This is the normalization based. This is the our layer normalization based prediction. This is the our without normalization based prediction. Now this is the performance measure with the different. Since we apply the sensitivity and specificity false positive and dice score, we calculated for the without nomination and with the nomination. Both table we infer that dice score of the LNN based architecture again 7.5% higher than without nomination based architecture. For DIMA, 12.5% higher than dice score for non-enhancing tumor, and 1.5% dice score for enhancing tumor. LN based model shows less false positive rate than without nomination based model for all three forms of cancer, and the LN based model is more generalized and exhibits significant outcomes of the random input. Now, this is the computer analysis. They are the different authors who apply the group nomination, and on the brain MRI dataset, they achieve the different values. There is the batch nomination, the instance nomination. This is blue color edema. This is non-enhancing tumor, and this is for enhancing tumor. Our proposed model is quite better from the existing techniques. In summary, we access the layer nomination technique for the 3D unit architecture. And additionally, we trained the 3D unit architecture without using any nomination approach. During the training phase with 50 approaches and batch size 1, the LN-based approach has given 32% reduction in validation loss compared to the without nomination-based approach. The tumor segmentation has also done better in empirical studies using LN-based architecture. By and large, layer nomination minimized the covariate shift effect during the training using its faster and learning more generic architecture. This is my references, and thank you.
Mr. Akhilesh?
Yes, ma'am.
You said, layer normalization have not been used. It has not been used in medical images. Have you said so?
I have reviewed many papers that I have not found any technique that used layer normalization in medical imaging.
But it's wrong. It has been there for a while, and people have used specifically layer normalization. You can see an ACM paper even now as the first result returned by the Google. I just checked about when you said such thing. And what exactly is reparameterization? What happens if you don't do that?
If we don't really apply the reparameterization, then the final result is make bias, because some pixels are belonging to other area and some pixels belonging to other class. Then we reparameterize all the pixels, all the values that belong to the same platform.
What happens if you don't do that, the reparameterization trick?
If we not reparameterize, then our classification are not well.
Have you studied that effect?
Yes, ma'am. I have studied in one paper, but not in detail.
Okay. Actually, when we talk about the batch normalization and all, we studied that the number of epochs it takes to converge to optimize the parameters will be dramatically reduced. Have you realized such thing that while you train your unit and other things with these normalizations, have you seen that it is not taking too many epochs to give you a better result?
Yes, when we use the batch normalization, it takes more time, and when we increase the batch sizes, that it's give the better result. But we reduce the batch sizes, but it is quite not acceptable. The results will come from the model. And we also see the apply the group normalization that are used that are applied with the author is called Jidis. Yeah, who and we also applied the group normalization, and also applied the we also applied the group normalization on this model. But we same we occur the same reduce the result. So we only apply the layer normalization because layer normalization have taken this is not bounded with the batch sizes. So we and our system not able to handle the more batch sizes when we increase the. So we apply the layer normalization technique.
What is the data set you used? Is benchmark one, or you have collected the data set?
This is the publicly available data set.
Okay, in that case, you could have compared your approach with the existing approaches who
Yes,
worked on the same data set, right?
They work on the broad data set, but they are the use older data set 2015 and 2014. We have used 16, but all the comparative analysis.
No, you mean to say that even the 2016 data set people would have used, and they have
Yes,
reported their results, right? So you can compare that to your layered normalized normalization based unit is performing so good like that when compared with those approaches. Because it is the gold standard data set available, right? So please do that.
Yes, okay, ma'am.
What is this?
Yes,
These are all the works.
Yes, and this is already works on broad dataset, and they apply the group normalization. They Hamid and total batch normalization applied. They instance normalization, and we apply the layer normalization on this dataset. They achieve the DICE score.
Okay.
So Akhilesh, none of the existing methods, so they use the batch normal, your layer normalization.
Yes, ma'am. We in the medical imaging field, there no one apply the layer normalization field, especially on Brad's MRI segmentation.
Okay, in that Brad's data set, only they have applied the batch and group normalization. You are claiming that you are the one who has applied this layer normalization. Is that correct?
Yes, ma'am. Because layer normalization, we did they apply the different natural language processing tasks, but in the medical field, especially in the Brad's MRI data, they are not applying the layer normalization technique.
Actually, applying data set is not the contribution, right? For medical imaging, if a layered architecture or layered normalization has not been used, you can claim that you are using, but you cannot claim that for that is evaluating this particular data set. I used layer normalization, which is performing good. That could not be the valid claim for you. Okay, so you need to write in your report, or you can write your paper like whether this layered normalization is not applied for any medical imaging.
No, but that just Bhuwana said that it has been
not,
applied.
It has been applied, but only considering this data set alone. Just think about it. Okay. So,
okay.
Refer to the papers which uses layered normalization, and you can really find out what is the research gap in it. And
okay.
Okay, thank you, Akhilesh. Yeah.
Okay.
Thank you, Akhilesh. Dear authors and chair members, so due to some technical problems, we are
Okay,
switching
he'll
the
join
link.
the
Yeah,
other-
yes. Thank you, authors, and thank you, chair members. So we will be rejoining in the another link.